Okay, for what we have at the start of chapter 3, okay, we have what will be regarded as Introduction to Determinants. And, okay, now we have for a matrix A, okay, we have for the top row, which we will be working with for those matrices that have 3 or more columns. Okay, we have for the top row, we have for the headings, we have A11, A12, and A13. And for looking at what are referred to as determinants, and we have by definition, okay, we have for n number of columns, okay, for n greater than or equal to 2, okay, we have the determinant of an n by n matrix, okay, to be the sum of n terms of the form. We have plus or minus a1j, determinant of a1j, with plus and minus signs alternating, where the entries a11, a12, and so on are from the first row of A. And we have the following formula, okay, that is given in symbols, okay, and which we have in compact form. We have with the summation as j goes from 1 to n, and we have negative 1 to the 1 plus j, a1j, determinant of a1j. And just looking at what we have going from the theoretical side to the practical. And let's say if we have square matrix, okay, where we have a 3 by 3, and we'll say that we have looking for the determinant of where we have a is equal to 1, 2, 3, 0, 1, 4, negative 2, 0, 7. And for what we have from the top row, here we have a11 is the first element from the top row, so we have it 1. A12 is the second, where we have it 2, and A13 is going to be at 3. And now we have corresponding to A11 equal to 1. If I'm looking for the determinant of A11, okay, that corresponds. What I'm going to do here is that I'm going to have 2 by 2 matrix formed. Okay, that will be outside the same row and the same column position as what we have with 1. So if I were to section out the first column and the first row, I would have this square pattern where I have 1407. So I'd be looking for the determinant of this. And for the second element from the top row, I have it 2. And for the determinant that corresponds, okay, I'm looking at sectioning out the top row and the middle column, and left exposed are 0, 4, negative 2, and 7. So I'll be looking for the determinant that corresponds. And for A13 equal to 3, again, for the corresponding determinant, you're looking at sectioning out the top row and the rightmost column, and we have left exposed. We have 0, 1, negative 2, 0. And taking what we have just from the algorithm, okay, so we have so you have A11, so you have it 1 determinant, okay, you have 1407, you have minus A12, so you have minus 2 times the determinant, and we have 0, 4, negative 2, 7, and you have plus A13, so you have 3 times the determinant of A13, so you have that of 0, 1, negative 2, and 0. So we're going back to 2 by 2 matrices and taking diagonal products. Okay, so we have 1 times. We have 1 times 7 minus 4 times 0. So you have 7 minus 0. And then we have minus 2. And we have with the diagonal products, have 0 times 7 is 0. And then we have minus negative 8, which would be a plus 8. And we have plus 3 times. Okay, and you have 0 minus negative 2. So we have addition of 2 once we rewrite the subtraction of a negative. So here I have 1 times 7 minus what's going to be 2 times 8, and I have plus 3 times 2, which will be 6, added at the end and combining. So we have 7 minus 16 plus 6, and for the overall determinant of A, okay, this will end up at negative 3. Now, okay, and again, just for the operations here, so I'll be operating addition and subtraction. For the odd number column positions, okay, we'll be looking at taking the addition of whatever the top row element is going to be, but for the even column positions, I'll be subtracting. Okay, so you have like plus 1, minus 2, plus 3, and if we were to go from a square 3 by 3 to a square 4 by 4, and we have, let's say you have alternating, so you have 1, 2, 3, negative 1, and your A11 is at 1, your A12 is at 2, A13 is at 3, and your A14 is going to be at negative 1. And for the matching determinants, okay, so we have, again, sectioning out the top row and the leftmost column. I have exposed one for 1, 0, 2, negative 1, negative 1, negative 2, 0. Again, corresponding to A12 equal to 2. If I were to eliminate the top row and the second column elements, I would have exposed 0, 4, 1, 1, 2, negative 1, 3, negative 2, 0. And then for 3, if I section this out, I have 0, 1, 1, 1, 0, negative 1, 3, negative 1, and 0 exposed. And we have with the last element in the top row, have at negative 1. For the corresponding determinant, if I were to section out the top row and the rightmost column, I would have 0, 1, 4, 1, 0, 2, and 3, negative 1, and negative 2 exposed. And just following along the lines of the algorithm. So you have, again, A11 minus A12. So you have 1 minus 2, and you have plus A13, which would be plus 3. Now I have minus A14. Now A14 is negative 1, and that's ultimately going to translate to a positive 1 from the subtraction of negative 1. And looking at the respective determinants from A11 all the way out to A14. So we repeat the procedure in the following steps as we did from the prior case. All right, so we have for the first setup, say I have 1, and then I have working inside, so I have 1 times the determinant. Okay, so covering up 1, top row, first column I have exposed to negative 1, negative 2, 0, and then I have minus 4, and you have times the determinant of the exposed element, so that would be 0, negative 1, 0, and I have plus 1. Okay, and you have times the determinant. Okay, so I have left exposed. I have 0, 2, negative 1, and negative 2. Okay, so I'm beginning this particular proceeding from this part, and then for the next I have minus 2, and just following through. Okay, so I have 0 times the corresponding determinant, and I have minus 4 times the 2 by 2 determinant that corresponds, and I have plus 1 times the corresponding determinant. And then we have next, I have plus 3, and I have times, again, I have 0 times the corresponding determinant, and I will have minus 1, and then I have plus 1, and then you have next in line, okay, so we have plus 1, and we have, looking at what we have column by column, so we have 0, we got 0, 2, negative 1, negative 2, we got minus 1, 1, 2, 3, negative 2, and I have plus 4, and I have 1, 0, 3, negative 1. And we can go ahead and eliminate some of the portions here because we have some items that will be negligible. Okay, so I have 0 times the determinant. Okay, this will go out. You got 0 times the determinant, that will go out, and this also goes out. And so for what we have in the process, okay, so you have from the front, you have 1, you got 1 times 0 minus 2 minus 4 times quantity of 0 minus 1, and I have plus 1 times, so it's going to be 0 minus negative 2, which would translate to plus 2. And then we have next, we have minus 2. Again, we can just start out with negative 4, and we have times quantity of 0 minus negative 3, or what would be 0 plus 3, and then we have plus 1, times quantity of negative 2 minus 6. And we have, just in the follow through, we have 3 times quantity of negative 1 times quantity of 0 plus 3, and we have plus 1 times the quantity of negative 1 minus 0. And then for what we have finally, we have 1 times quantity of negative 1 times negative 2 minus 6 plus 4 times quantity of negative 1 minus 0. And just for what we have in the stretch, so just collecting what we had inside the parentheses, we're going to have 1 times 4 minus 2 times negative 20 plus 3 times negative 4. And we have plus 1 times 4. And so just bunching what we have together, we have 4 plus 40 minus 12 plus 4 is equal to 36. Okay, so if you look at it column by column, again, for items that are in the odd number column position, you're looking at adding. For those that are in the even number column positions, we're looking at subtracting.